All right, on this problem, we're going to do, again, a KSP problem, but in this case, it's a Q. So basically what a Q is will a precipitate form or not precipitate? Now, I don't want to write that out, neither does anybody else. So remember, precipitate is abbreviated PPT. So the question here is anytime they ask you, will a precipitate form, then it's a Q problem. Now remember, Q is equal or greater than KSP when a precipitate forms. So in this case, the question is whether it will form or not. So what we have to do is get a Q value, and Q, remember, has the same as KSP. We're doing a zinc hydroxide, so this is zinc 2 plus times hydroxide minus, okay, and we're given the value right there. So then the question is we're mixing sodium hydroxide. That gives us our hydroxide plus the zinc chloride solution. Okay, fine. So if we're mixing two solutions, then we end up with a new volume. So we're going to have 85.5 milliliters plus 200.5 milliliters, which are the values of each. And so we're going to end up with a total volume of 286 will be our new volume. Now, if you're not mixing two solutions and the question just asks, will a precipitate form as you raise the pH or add more of a thing, a particular ion, then you don't have to do the dilution. But here we do. So zinc 2 plus is going to be 200.5 milliliters times 0.018 molar divided by 286 milliliters. Now, that value is 0.012618. Now, I'm going to write out more digits, but I'll only use the 4 digits by rounding. Okay? The hydroxide ion concentration value is 85.5 milliliters times 0.0054 molar, again divided by 286 milliliters, which gives us a whopping value of 0.00161434. And again, I'm going to stick with 4 digits rounding. Okay? So my Q value is going to be equal to 0.01262 molar times 0.001614 molar, and again it's got to be squared. So Q comes out equal to 3.2875 times 10 to the minus 8th. So if you look at Q with respect to KSP, Q is 3.2875 times 10 to the minus 8th, and remember KSP was 1.2 times 10 to the minus 17th. Well, minus 8th is way bigger than minus 17, so Q is larger than KSP, so it will shift back to the reactant, so that translates to yes, there is a precipitate formed. Okay, now then the question becomes, if yes, what is the pH needed to stop precipitation? If no, what is the pH needed to start precipitation? Well, on the part 2, okay, what we're really looking for is the pH is going to be equal to the hydroxide ion concentration, which we can relate to the hydroxide ion concentration through the pOH. So all we have to do is figure out when precipitation stops or starts. Well, since we know it already is going to start at, it will be precipitating here, what we really need is when Q becomes less than KSP. Okay? So the easiest way to kind of do that is Q is, you can go equal to and just remember to reduce it, or you can stick with less than KSP, which means that you're going to have the value. So remember, Q less than KSP, we need zinc 2 plus times the hydroxide ion to be less than 1.2 times 10 to the minus 17th. So, we've got to assume that we're keeping the concentration of the zinc chloride solution. So what we'll start with is that we're going to use the original zinc concentration because we don't know what our final dilution is on this one. So we're going to use that as our molarity. So what we'll do is we need 0.018 molar for zinc. We don't know what the hydroxide ion is. We need that to be less than 1.2 times 10 to the minus 17th. So that means our hydroxide ion concentration is going to be less than 6.666 repeating times 10 to the minus 16th, which means if we take the square root of both sides, then we end up with the hydroxide ion concentration has got to be less than 2.58198 times 10 to the minus 8th, which means that if we're looking at it, then our POH has got to be less than 7.5880. And remember, pH plus POH is going to be equal to 14. So the question was the pH. So our pH is got to be less than 6.41 value. All right, so if we look at this, any pH above 6.41 is going to cause precipitation. At 6.41, it will start. So we're looking for less than that. You could have set up the whole problem with it equal to, and then in the answer, you just know that it's got to be less than that, and you're good. Okay? Now, you could have originally set up the entire problem and figured that out accordingly. But we're good to go on this problem now.